Hi physics lovers, welcome to this online tutorial lesson. Today we shall be solving problems on error analysis. So problem number 1 says, given that x equals this, where k, l, m, and n are variables, state the maximum percentage error in x. So solution, this is a maximum percentage error. So we have percentage error in x will be a from, of course, I've treated this before now. If you have not watched the video, do well to go back to our previous video, our previous discussion on error analysis. So percentage error in x, maximum percentage error in x should be combination of the errors in k, l, m, and n. So you have a, you have a percentage error in k, plus you have b, percentage error in l, plus you have c, percentage error in, this is percentage error in m, plus d, percentage what, error in n. So this is how to state the maximum percentage error in x. So it's a combination of the errors in k, l, m, and n, since k, l, m, and n are what? Variables. Assuming we know the values, we can go ahead to find the errors. So question number 2 says, if v is given as pi d raised to power 2 l upon 4, where l is this value in cm, this is the limit estimate maximum error, this is d, okay, in the same units, this is limit estimate maximum error. Determine the maximum error in v. If v stands for volume, how do we find the maximum error in v? So solution, so to find the maximum error in v, solution, this is maximum error in v, we shall use this to represent it. So maximum error in v, from the formula we know before now, say maximum error in v upon v equals, the pi here is a constant, so we have, since this is to the power, we have 2 maximum error in d upon d plus maximum error in l upon l. The 4 is a constant, so we shall not going to consider it. So if we make maximum error in v subject of the formula, we are getting answer to number a. So how do we do that? To have v, then you have 2 maximum error in d upon d plus maximum error in l upon what? L. So you see, in this problem, we don't know the v. How do we get the v? From this formula, v, we don't know it, so v is pi d square l upon 4, and d is given as, the actual value for d is 2.1, so we say 2.1, we square it times l, the actual value of l is 8.9, this is 8.9, then we divide by 4. So if we do this multiplication, we shall be having, this is 30.82 cm what cube. So we have gotten the value of v. So we can now come to this formula and replace. We have 30.82. So you have 2 times the maximum error in d, this is limit estimate maximum error, is 0.1. So this is the maximum error in d upon the value of d. The actual value of d is 2.1 plus the maximum error in l is 0.1, and the actual value of l is 8.9. Once you do this math, you have, so once you do this math, you have that the maximum error in v is approximately this is approximately 3.3. So this is the maximum error in v. So we can report v now as v. If we want to report it, okay, we can neglect this decimal place. We can report it as, approximate this, we have it as 31 plus or minus 3 cm what cube. So we have solved we have provided the answer for A. A says determine the maximum error in V. So the maximum error in V is this. Now, B says obtain the maximum percentage error in V. How do we do this? So we want to obtain the maximum percentage error in V. The maximum percentage error in V will be percentage error in D and percentage error in L. And we know that percentage error, it can also be called fractional error or relative error. Percentage error is given as error upon actual value times 100. So this is the formula for finding the percentage error. So how do we now find the rest? So we want to find the maximum, that is, we are solving B now, the maximum percentage error in V. So let us find the percentage error in L. It will be error in L upon L times 100. So error upon actual value times 100. So we have 0.1 as error in L upon the value of L is 8.9 times 100. So once we do this, we have approximately 1.1 what percent. So to find the percentage error in D, it will be, of course, from what we did earlier, it will be 2 error in D upon D times 100. So this will be 2 times error in D. 2 times error in D is 0.1 upon 2.1 times 100. Once you do this math, you have approximately 10%. So you have approximately 10. This is 10%. 10%. So the total error in V will be approximately 11%. Total error in V is approximately 11%. So the question is asking again, from the above, what can you say about the instrument used in measuring D? So we can say that the instrument used in measuring D is not sensitive. The accuracy is poor. So we therefore recommend that a more sensitive instrument should be used in measuring this D so as to increase its accuracy. Of course, you see that this is 10%. 10% is more than 1. You see? So a more sensitive instrument should be used to measure this diameter so that the error will reduce. So let us look at the next question. So this problem is asking us to calculate I and its standard error. So how do we go about this? To calculate I is given as, this is B D square upon 12. And B is the actual value of B is 2.6 times D is 0.65. We square it upon 12. Once we do this math, we have approximately 0.09. So we have 0.09. So it's asking again that we should find the standard error. Of course, you see, to find the standard error, we make use of this formula. Standard error in I upon I equals, the variables we have here is B and D. So we have standard error in B, okay, upon B, we square it, plus 2 standard, the power here is 2, so 2 standard error in D upon D. We square it and we find the square root. We find the what? Square root. So this is a constant. The 12 here is a constant. We're not going to make use of it. So going further, we have that standard error in I is I. This is square root. From the law of indices, we have square root of, okay, we have standard error in B upon B. We square it, plus 2. This is 2. Standard error in D upon D. We square it. So once we do this, we have found the standard error in I. Since we have calculated I, so we go further to say this is standard error in I equals, the value of I is 0.09. So we have square root of the standard error in B. This is limit estimate standard error is 0.01. So we have 0.01 upon the actual value is 2.6. So we square it plus 2 times the standard error in D is this is D 0.01 again, so we have 0.01, okay, upon the D actual value of D is 0.65. We square it and find the square root. So going further to solve this, we can represent this as a gram cm what square, because the unit of moment of inertia is kilogram meter square. So let's have this unit as gram and have this unit as cm. Of course, this is we have squared this. Cm times cm will give us cm square. So once we do this mass, we have approximately 0.003 watts. Okay, 0.003. This is standard error. So since we have this in 2 decimal places, we can have it as, we can now report our I as 0.090 plus or minus 0.003. So the I we have calculated is this, and the standard error in I is this. If you have enjoyed this video up to this point, do well to share it with your friends. Comment on the areas you would want us to treat next. Now let us look at another problem. So this question says, if a couple mg capital R is applied at the end of a wire, the angle of twist at a distance L from the fixed end is given by this. Calculate N and E standard error given the following values. You have values of theta, value for M in kilogram, value of L, length in meter. Okay, value of A in meter also, value of R in meter, and value of G in meter per second square. So how do we go about this? Solution. So to do this, we make N theta of 21. Remember, we are told to assume that the errors in M and G are negligible. So we're going to neglect that. So what we do now is to make N subject to the formula. We cross multiply, have NA to the power of 4 theta equals 21 mgr. This 21 is a constant. So once we make N subject to the formula now, we have 21 mgr upon, this is A to the power of 4 theta. So since we are told to take this to be negligible, M and G, so our interest here will be an R, A, and theta, because this 21 is a constant. So how do we find the standard error in N? So standard error in N upon N equals, the variables here are this. So we have standard error in R upon R, we square it, plus, this is to the power of 4. We have 4 standard error in A upon A, we square it, plus we have a standard error in theta upon theta, we square it, and we find the what? We find the square root. So this is how to find the standard error in N. So we have that standard error in N equals N, then we replace this. This is square plus have 4 standard error in A upon A, we square it, plus standard error in theta upon theta, we square it. In this case now, we need to find N. How do we find our N? From this that we have done, we know that N will be 21 times the value of the actual value of the mass given is 3.5. So we have 3.5 times R is given as, the actual value of R is 0.074. Have 0.074 upon, so the actual value of A is 0.0047. So 0.0047, we have to take it to the power of 4 times theta. The actual value of the theta is 0.2. So once we do this math, we have, we are having that N is 5.45 approximately, okay, times 3 to the power what? 11. So we have gotten N. Now coming here, we now have that this will be 5.45 times 10 to the power 11. This is 10 to the power 11 as the value of n. Then we find the square root of this. The standard error in r, this is r. Where is r? This is we have t. Okay, this is r, is 0.001. So you have 0.001 upon the actual value of r is 0.074. So we square it plus, this is 4 times the standard error in a. This is a, is the standard error is this. Limit estimating standard error is 0.0001. all right, upon a, the actual value is 0.0047. we square it plus, then the last one, the standard error in theta, this is theta, is 0.009. 0.009 upon theta, the actual value is 0.2. we square it. So once we square this and find the square root, then multiplying it with this, we find that the standard error in n is now. So once we do this math, we have that standard error in n is approximately 0.53. So this is the standard error in n. So this problem is saying, since measurements were made of time for 20 oscillations of mass hung from spring as follows. So we have, let's say, number of oscillations is 20. Number of oscillation is 20. So n equals 20 oscillations. Okay, and period is the time it takes to complete an oscillation. So if we have this as the different times, okay, we have 6 measurements. This is the first, the second, the third, the fourth, the fifth, and the sixth. And the times we have, this is 20.1. okay, so this is 20.2, 20.3, this is 20.1, 20.0, and 20.2. So how do we find the period for this one? So the period will be, for this one, we have t equals, so after 20 oscillations, the time is taken to have this. After another 20 oscillations, the time is recorded as this, and so on, up to 6 measurements. So we have 20.1 upon 20, we have, so once we do this division, we have 20.1 divided by 20, we have 1 point, okay, we can say 1.01, approximately 1.01, so I have 1.01. And to make this to be in 2 decimal places, we can have this as 20.10, 20.20, 20.30, 20.30, 20.10, 20.00, and 20.20. So going further, we'll now have, let's do this. For this, we have t, this is for the first one. For the second one, we have 20.20 upon 20, number of oscillations. So we have 20.20 divided by 20, we have 1.01. So we have 1.01. So doing the same again, T3 will be 20.30 upon 20. We have 20.30 divided by 20. We have approximately 1.02. So for the fourth one, we have that 20 points. Okay, this is the fourth one, 20.10 upon 20. We have got it before as 1.01. So for the fifth one, T5, we have this 20.00 divided by 20. So this will be 1.00. So that is 1.00. So the T6 will be 20.20 divided by 20. It will be approximately, it will be 1.01. So we have found the period for this, and for this. So to find the mean t, we now have T1 plus T2 plus T3 plus T4 plus T5 plus T6. Then we divide by 6. So we have got T2 to be 1.01, T3 to be 1.02, T4 to be 1.01, T5 to be 1.00, and T6 to be 1.01. So to find the mean value now, we use this. So if you find the mean for this T1, okay, this is T2, this T3, T4, T5, T6, you have it as 1.10. So you have 1.10. So this is the mean value of the period of oscillation. The question says, find the mean value of the period of oscillation. And the standard, this is standard, and the standard error in this value. So how do we find the standard error in this value? So since we have 6 measurements, so we have 6n. So for us to find the standard error in this measurement, we use this formula: x equals w upon n, where this n is the number, w is the range of the values, So what is the range of these values now? Of course, in this case now, it will be the range of the period, because it's saying find the mean value of the period and the standard error in this value. So how do we go about that? So this was possible because our n is 6. So for us to use this approximation, actually this is an approximation, the n should be within this range, should be within this range. So it should be within 3 and what? 12. So for us to use this formula, we now say that x equals, the w is the range. Okay, we have something like this is 1.02. Okay, 1.02 should be greater than 1. So we have 1.02 minus 1.00 divided by the n there is 6. So once we do this, we can call this is the standard error of the mean of the period. So we have it as this is 0.003. This is 1 to 3. 3 times 3 is 12 minus 3. So this is the standard error of the what? The period. So I can say, write this as the standard error of the period. Okay, and this is the mean period. So of course now we can write the value of the period as this: t equals 1.010. Okay, so that it will look like this, plus or minus 0.003. But the question is asking us to find the mean value of the period, which we have found, and the standard error in this value. So we have utilized this formula to find the standard error. If you have enjoyed this video up to this point, do well to share it with your friends, and don't forget to comment on the area you would want us to tweak next. Now let us look at another question. All right, this one is saying if x equals this, y equals this, and z equals this, and u is giving us the addition. So the question says calculate the maximum error in u. So we have done this before. So how do we find the maximum error in u? So we say maximum error in u will be error in x plus error in y plus error in z. And the maximum error, okay, limit estimating maximum error in x is 0.05. In y, we have it as 0.01. And in z, we have it as 0.02. So if we add this, we have 0.08. So we can report the value of u in terms of its maximum error as, of course, we can add the u, the actual value. The u is 10.10 plus, this is for x, this is 6.03, and this is 3.04. We have 19.17. So we can report u as 19.17 plus or minus 0.08. So the value of u lies within this. So, and this is the maximum error. So from our previous video, if we take this now, these values as the standard error, you should find the standard error in u. So put the answer in the comment section. So if you have enjoyed this video and you want to see more of this video, subscribe to the channel and share it with your friends. This is Nesalifa Academy, and we are signing out.